Problem 5 describes Joan and Steve who are driving from Bellevue to Spokane and Spokane to Bellevue. The distance between Bellevue and Spokane is 280 miles. T is going to be time in hours measured from noon, so T equals 0 is noon, and T equals -1 would be 11 a.m. Part A asks us to find a function j of t that computes her distance from Bellevue at time t, and then sketch a graph specifying the domain and determining the range when she's driving from Bellevue to Spokane, leaving at Bellevue at 11 or t minus 1, and arriving in Spokane at 3:30 p.m. or t equals 3.5. So I drew just a little picture describing what that looks like, where the x-axis is time in time in t equals hours past 12 p.m. So that 0 being 12, -1 being 11, and 4 being 4 p.m. Then I also represented x equals 0 as Bellevue, and then x equals 280 as Spokane. I drew out j of t, which is Joan's line. She starts here at 11 a.m. in Bellevue, or at x equals 0, and then gets to Spokane at 3:30 or 3.5 up here, or at x equals 280. And then I did the same thing for Steve, except I started him at 280 or Spokane at 12 p.m. and then had him arriving at 0 at 4 p.m. So to find Joan's travel, we just use the distance equals rate times time formula. Our distance being 280, our rate being our time being 4.5 hours, which is the difference between 11 and 3:30. And then finding r, we know that she was traveling 62.2 miles per hour. So the formula of her line looks like is j of t equals 62.2 t plus 62.2. Then Steve's line is just going to look like -70 because he's going 70 miles per hour, but this time on our graph he's going down with a negative slope. And then him starting at 280, which is what this is the y-intercept 280. For Joan, the domain is going to be from -1 to 3.5, and then for Steve, in the range is going to be between 0 and 280, and then the range is going to be between 0 and 280 for Steve again, but the domain is going to be between 0 and 4. So the next part of the problem is a little bit more complicated. It asks us to find a function d of t that computes the distance between Joan and Steve at time t, and it's important for us to make the assumption that prior to Joan leaving for Spokane from Bellevue, she's at 0 the whole time, or she's in Bellevue prior to. So I drew this line a little bit thicker to kind of represent that in all the hours prior to 11 a.m. she's still in Bellevue, and same with Steve. Prior to 12 when he leaves, he's still in Spokane. So then what we need to do is break this into a three-part function where we look at where the distance is between them up until Steve leaves at 0, or in other words, when his line starts moving. Then find a function for how far apart they are when they're both moving at the same time, and then find the difference between their lines when just Steve is moving between 3:30 and 4. So the part 1 we can figure out by just saying between t equals -1 and t equals 0, the distance between them is going to be 280 minus 62.2 t plus 62.2, and just use a little bit of logic here, doing the distance of Steve, or s of t, minus j of t, except s of t between -1 and 0 is 280. So that's why we put 280 there. And then we minus j of t, which is just going to be the formula we found earlier. Then between 0 and 3.5, that's going to be when they're both moving. And we do the same thing, S of t minus j of t. And since they're both moving, that's going to be both of these lines. We can just use the line of one minus the line of other, which is what we've put here. I simplified or distributed and combined like terms to get negative 132t plus 217.8 is d of t between, or when t is between 0 and 3.5. And then for the last one, we do something similar to the first part, where we understand that it's still S of t minus j of t, except for that for j of t, for the last half hour that Steve is traveling, she's been in Spokane or at location x equals 280. So we just do between 3.5 and 4. The distance is the absolute value of negative 70t plus 280, which is S of t, minus 280, which is j of t, equals d of t. And the reason why we do the absolute value is because if you plug one of these, plug a number in for t, what you're going to get without the absolute values is a negative value, and you can't have a negative distance, even though we could probably deduce that if it was, negative 200, for example, it would still mean that they're 200 miles apart. But just for the sake of making this formula foolproof, we're going to put the S of t minus j of t in absolute value.